Hello everyone. Let's talk about some of the DML statements that HQL provide. One of them is load. You already know what load does. So it can load data from a file which is stored in local file system or HDFS to a table. So what load does is it takes the file as input and you provide the table name in the load statement and it is loaded to the directory where the table is stored, mentioned in the Hive Metastore warehouse directory. But you already know that behind the scenes, it does a copy of the file from one file system to another. For example, if the file is in local file system or HDFS, it will be copied from there and to the directory that is mentioned in Hive Metastore warehouse directory. It can be HDFS or it can be S3 also. And that's what load does. We can load an entire table, or if you have a partition table, you can load individual partitions using the load statement, which you have already seen in the previous demo. There are two things that you have to remember and load, and one of the important things is that there is no transformation. So data is just copied from one location to another. That's all. It does not read the records from the file, or it does not write the records to a file. So it's a copy of a entire file from one location to another. Let's talk about insert statements. Again, if you use insert into statement, you append to the table. If you have a table and you write the insert into statement, the record would be inserted to the table. If the table already has records, the additional records would be appended to it. But insert override is a little different. It will override the existing data, meaning let's say you already have records in the table and you run the insert override statement, then all the current records will be deleted and new records would be inserted using the override statement. You can insert to a table or to a partition. We have already seen this. One very important thing that insert does is transformation, meaning it reads the records from the files or from the source system. It can be a source table also, and then before writing to the target table, it checks a lot of stuff. If it has to change from one format to another, it will do that also. So far we have used insert statement in dynamic partitioning. In dynamic partitioning also, insert checks the record, checks the partition key, and then inserts the record into its corresponding relevant partition number. You can read from CSV or any other files, any other text files, and insert into ORC Parquet file formats. You can use other file formats also. You can also insert into a table by selecting records from another table, and this is what we have done in dynamic partitioning. We inserted records into car sales data dynamic partition table by selecting the rows from car sales data table. Let us do a short demo of insert statement. I have dropped the other tables. I only have cart sales data and cart sales data part as of now. What I'll do is that I will create a ORC table and a Parquet table, and I will insert records in those tables by reading data from cart sales data. I have a file, but to read from file and then insert into the Parquet and ORC tables, I'll need a script. I'm not creating any script, so what I'm doing is that I'm selecting the records from cart sales data and inserting into those. This is the Parquet table. Name of the table is cart sales data Parquet, and the file format is also Parquet. Now I'm inserting records in cart sales data Parquet by selecting from cart sales data, which has initiated a TASE DAG task. So there are transformations. So if you have transformations, obviously Hive would create MapReduce tasks. So in this case, TASE DAG MapReduce tasks. So the task will go ahead and do the transformation. I'll change the record format into ORC and then write to the target table, which is done by now. If I go to S3, I should be able to see the cart sales data Parquet folder. And in this folder, I have only one file, which is actually in Parquet format. I can do the same for ORC tables also. What I'm doing here is that I am creating a table with 4 buckets, and the key that will be used to create the to store the records in individual buckets is product ID, and the table will be created as ORC. So this is an ORC table. Now I'll be inserting records into the ORC table by selecting them from cart sales data. It should create a Tez DAG task because this would also include transformation, as we are loading from a CSV or a text file to an ORC file. The record has been loaded. I can see the records from ORC table, and if I go to S3, car sales data ORC has been created, and there are 4 files. The reason we have these 4 files because we have 4 buckets 0, 1, 2, 3. So that was a small demo on insert. Let us continue. The next one is select. I do not want to spend too much of time on select. This is the select statement. There's this with common table expression also. So Hive supports CTE. If you do not know what common table expression or CTE is, it's okay. That is perfectly fine. And this is a typical select statement where you run the select command followed by the select expression and then mention the table name, mention where condition, group by, order by cluster by, etc. There are 3 things that I wanted to mention. The first thing is order by. So when you mention order by, order is maintained for the entire result set, meaning let's say you have 1 million rows in the result set. So the select statement returns 1 million rows and you mention order by. All those 1 million rows will be ordered based on the order by column. There's something called sort by also. So sort by does not order completely for the entire result set. In sort by, ordering rows are maintained within a reducer. We have already seen the number of mapper and reducer tasks in Tez. It can be map reduce or Tez DAG. So for both the cases, we have reduce tasks. So if you use sort by, the sorting is done per reducer task. That means the result set, the 1 million rows will not be completely ordered based on the column. It will be partially ordered per reducer. And finally, I wanted to talk about local mode. So what happens is that there's a configuration parameter. If you set the configuration parameter, the select statement will return the rows without running map reduce or Tez tasks. This is the configuration parameter, Hive exec mode local auto true equal to true. By default, it is set to true. And I hope you have noticed that whenever we ran this select statement from select star from some data limit, even though when you mentioned where clause, EMR, Hive on EMR did not run on any Tez DAG tasks. So this is the local mode. So what it is doing is that Hive is going and reading the file directly. It is not writing any map or reduce task or Tez task to do the processing. So this is what local mode is. The next stop is ACID transactions, using which you can run update and delete statements. So ACID transactions are used to run update and delete statements, but there are a few limitations. One of the major limitation is that it does not support begin, commit and rollback statement like RDBMS. So you cannot have a transaction of multiple HQL statements. So it has to be only one statement. Only ORC file format tables support ACID transactions. So if you use any other file format like Parquet, text file, RC file, etc., ACID transactions will not be supported. So it has to be ORC file format only. On top of it, the table has to be bucketed. So you have to create buckets for that particular table. If you do not create bucket, then you cannot run transactions on that particular table. So there are few configuration parameters that you have to set before running the ACID transactions, like Hive transaction manager has to be set to Hive QL log manager DB transaction manager. Hive support concurrency should be set to true. Hive enforce bucketing should also be set to true, and dynamic partitioning mode should be non-strict, which I have not mentioned here, but you have to make sure that that is set to non-strict also. And there's one more thing: when you create the table, in table properties, you'll have to mention this transactional to be true. What happens in this ACID transactions in update, insert, delete? So we have these base files that we have already seen in S3. So whenever you create a table and load records or load data into those tables, these base files get created. So when you run update or delete statement, those update and delete statements are not run directly on the base files. they are run on something called delta files. So let's take an example. So let's say you have two buckets. You have created a table with two buckets and all of your data are there in these two buckets. So these are the base files, and if you run update or delete statement, it will create something called delta files. So all the updates and deletes would be recorded in these delta files. Each bucket would have its corresponding delta file. So in this case, bucket 1 would have delta file 1 and bucket 2 will have delta file 2. So it does not change anything on the main base file. All the modifications are captured in delta file. So you might imagine if you have a lot of buckets, let's say 10, 12 or 20 buckets or maybe more, and you are running update or delete statement in each of these buckets, then each of those buckets will create its own delta file. Now there can be a lot of delta files. So there's a process called compaction which runs in the background asynchronously. The compaction process merges these delta files with themselves and with the base files. So there are two types of compaction. One is minor compaction, wherein it takes a set of existing delta files and rewrite them to a single delta file per bucket. So if bucket 1 has, let's say, 10 delta files, all of them would be merged together into a single delta file. And bucket 2, let's say, has 5 delta files, those will be merged together and a single delta file would be created out of it. Then there's major compaction. It takes the delta files and the base file for the bucket and rewrites them into a new base file per bucket. Let's take the example again. So you have bucket 1 and let's say bucket 1 has 10 delta files. If you run major compaction, it will take the base file of the bucket and all the 10 delta files, it will merge them together and create a new file for bucket 1. Similarly, let's say bucket 2 has 5 delta files. The base file for bucket 2 and the 5 delta files would be merged together to generate a new base file for bucket 2. One thing I want to mention here is that if you want to use ACID transactions on Hive tables or ACID transactions on your data lake, like you want to run update, delete, insert statements, it's better to use table formats like Hoodie and Iceberg rather than using ACID transactions on Hive itself. It's better to have a table format on top of your data lake. In our case, it will be AWS S3, and then use those table formats to run ACID transactions. The next topic is materialized view. It is similar to a table, but it stores the result of a query. So you can create materialized view like this. So create materialized view. So if you see, all the options are similar to that of a table. You have partitioned on, clustered on, row format, file format, and location. Then at the end you have this as statement wherein you will mention the query. So the result of this particular query would be stored as a table in materialized view. After creating the materialized view, which has been created from a table, so and let's say the table gets updated, you have new records or old records which have been deleted, etc. Then you have to refresh the content of the materialized view to keep it up to date with whatever changes that have been executed on the base table. So to do that, you run this materialized view rebuild statement. So what it will do is that it will go ahead and add the changes on the base table to the materialized view. So the refresh is incremental by default, but if for some reason the incremental refresh is not possible, then it will fall back to full rebuild. If you run insert statement, by default it runs incremental refresh. If you are running update or delete statement, then full rebuild would be triggered for the materialized views. I wanted to talk about index, but indexes are removed since Hive version 3. In EMR, we are using Hive version 3.1.3, so indexes cannot be used there. Instead of using index, you can use materialized view also. Then I wanted to touch base on view. View is exactly similar to that of views in RDBMS or relational database. In Hive, you create a view as select statement, and whenever you run a query on that particular view, the underlying select statement will get executed and then the results would be returned back to the client. So let's say I have created a view which is backed by a complex SQL statement, And if you run the view, if you want to select data from that view, let's say 10 times in a day, then the underlying SQL statement would also be run 10 times, and then the result set would be returned as a view.